Hi guys, welcome to Sabonzy Academy. So in this video, we'll be solving the question 12 of the 2019 Nov-Dec core maths theory questions. So we'll begin with question 12a. The points P, Q, and R are located such that Q is 15 kilometers south of P. R is 10 kilometers from P on the bearing of 270 degrees. Calculate correct to I, two significant figures, the length of QR. II. Calculate correct to the nearest degree, the bearing of Q from R. So let's move on to the solution of question 12a. The points P, Q, and R are located such that Q is 15 kilometers from P. So if this is P, our Q, which is 15 kilometers, and R is 10 kilometers from P on the bearing of 270. So this is our point P. R is 10 kilometers from P on the bearing of 270. So in core maths or in mathematics, bearing is taken from the North Pole. So if we have our Y and X axis, we have our north, south, east, and west. So the bearing is always taken from the north in a clockwise manner. So we start from the north in a clockwise manner. So we know that R is 10 kilometers from P on the bearing of 270 degrees. So from P, 270 degrees will be here, from here to here. So we have our R here. And the distance from P to R is 10 kilometers. So, and we have our Q here. So we can connect Q to R. The whole of this is 270. So from here to here is 270. And then from here to here is 180. So we can say that from here to here is 90 degrees. So this will be 90 degrees. And this gives us a right angle triangle. So when we draw the right angle triangle, it will look like this. So we have our R, P, Q. From R to P is 10 kilometers. From P to Q is 15 kilometers. And we have our 90 degree. Now we are being asked to find the length of QR. So this, and we know that the length of QR is our hypotenuse. So H. From Pythagoras' theorem, we can say that H squared is equal to 10 squared plus 15 squared. Now our H squared will be equal to 100 plus 225. So H squared will be equal to 325. Now to find H, we take the square roots of both sides. So we have H squared is equal to the square root of 325. This cancels this. Our H will be equal to 18.0278 kilometers. But we are being asked to correct our answer to two significant figures. And so our final answer, H, will be equal to 18.0 kilometers, corrected to two significant figures. So then the length of QR, which is equal to H, is equal to 18.0 kilometers. Now that brings us to the end of question 12AI. So moving on to question 12AII. It says, calculate correct to the nearest degree, the bearing of Q from R. So the bearing of Q from R would be this, which is our theta. So we can say that, so for 12AII, you are being asked to find the bearing of Q from R. So the bearing of Q from R will be the whole of this from here to here. But we know from here to here is 90. So we need to find here. This is 90. So we need to find theta. And we can say that tan of theta is equal to 15 divided by 10. And this is equal to 1.5. So when we find the tan inverse of 1.5, theta should be equal to 56.31. So AII. We can say that the bearing of Q from R is equal to from here to here, which is 90, plus from here to here, which is theta. So it should be equal to 90 plus theta. So this is equal to 90 plus 56.31. And this should give us 146.31 degrees. But then we are being asked to correct to the nearest degree. And so our final answer will be 146 degrees. That's to the nearest degree. So this brings us to the end of question 12A. Now we'll be moving on to question 12B. Now don't forget to like and subscribe, and don't forget to leave a comment in the comment section. So for the question 12B, find the quadratic whose roots are 3/4 and -4. So a quadratic equation takes the format x squared minus sum of roots times x plus the product of roots. So the sum of roots will be equal to the first root, which is 3/4, plus the second root, which is -4. And this is equal to 3/4 minus 4. And this should give us -13/4. Now the product of roots should be equal to 3/4 times -4. And this should be equal to -3. So our equation will be equal to x squared minus the sum of roots, which is -13/4x, plus the product of roots, which is -3. So our equation becomes x squared plus 13/4x minus 3. Now to get rid of the fraction, we multiply everything by 4. So our equation becomes 4x squared plus 13/4x times 4 minus 3 times 4. So our equation will be equal to 4x squared plus 13x minus 12. This brings us to the end of question 12B. So we'll be moving on to question 12C. So for question 12C, if cos t is equal to 4/5, such that t is between 0 and 90, find without mathematical tables or calculators the value of 1/1 minus sine t minus 1/1 plus sine t. So we know that t is between 0 and 90. So between 0 and 90 will be here. This will be our t. Now we know that cos is equal to adjacent over hypotenuse. And from our question, our cos is equal to 4/5. So we can say that our adjacent is 4 and our hypotenuse is 5. Now we know our hypotenuse and we know our adjacent. So we are left with our opposite. So when we take the right angle triangle, we have 5, 4, and so from this right angle triangle, we can say that 5 squared is equal to O squared plus 4 squared. So O squared will be equal to 5 squared minus 4 squared. So O squared is equal to 25 minus 16. Now 25 minus 16 is 9. So O squared is equal to 9. Now to find O, we take the square roots of both sides. So we have square root of O squared is equal to the square root of 9. So our O is equal to 3. So we have 3 here. Now to find sine of t, we know that sine is opposite over hypotenuse. So sine t is equal to opposites, which is 3 over the hypotenuse, which is 5. Now we are being asked to evaluate 1 over. So we are evaluating 1 over 1 minus sine t minus 1 over 1 plus sine t. So this is the same as 1 over 1 minus 3 over 5 minus 1 over 1 plus 3 over 5. Now this gives us 1 over, so 1 minus 3 over 5 gives us 2 over 5 minus 1 over 1 plus 3 over 5 gives us 8 over 5. Now this is the same as 5 over 2 minus 5 over 8. So 5 over 2 minus 5 over 8 is equal to 15 over 8. And this is the same as one whole number, 7 over 8. So this brings us to the end of question 12C. So we'll be moving on to the question 13 of the 2019 Nov-Dec Core Maths Theory questions. Now don't forget to like, comment, and subscribe. See you next time.